All right. So lesson 45, Algebra 3, what this is talking about is conditional permutations, two-variable analysis using a graphing calculator. So conditional permutations, these are fairly easy. You've seen conditional permutations in Algebra 2, so it shouldn't be a completely new concept because you had to have Algebra 2 when you came in. So it shouldn't be too out of line. And we've talked about permutations. We just haven't talked about conditional permutations. So we're putting a constraint on the permutations that we've done up to this point. So we see that, and then we'll get into the two-variable analysis a little bit later, which that's where we're going to be looking. We're going to use the stat function in our calculator. So we're going to be putting things in for list 1, list 2, and doing, one variable statistics, two variable statistics, and it should give us an equation for a line. So our calculator is going to do most of the work there. So the easiest way to do a lot of this stuff in lesson 45 is just to look at the questions that we have. For instance, it says how many three-digit counting numbers less than 700 have digits that are all odd. So if you've got that page up, I'm going to scroll over to a blank page. Okay, and I want you to think about this here for a little bit. Okay, it says how many three-digit counting numbers. So I'm going to make 3 spaces, okay, because I need a three-digit counting number, which means we're not working with a decimal, we're not working with fractions, we're working with whole real numbers, okay? How many three-digit counting numbers less than 700 have digits that are all odd? So the easiest thing to do is to start with your largest number and work your way down from the hundreds, the tens, the ones. Okay, so we need digits that are all odd, and it has to be less than 700. So we can't include 7 in our hundreds digit spot, right? Okay, so what digits would be included? But they have to be odd. So you're correct. 1 is 1. 1, 3, and 5. Okay, so what we put up here is how many of them. So we have 3. Okay, and then I go down to the next one. Now, the important thing to remember in situations like this is 0. 0 is technically, 0 is kind of an odd thing, is that 0 counts as an even number when it's in the single digits position. Okay, so when it's in this position right here, it counts as an even number, just like 10 is an even, right? 320 is an even, right? Okay, but when it's, let's say it's in the tens position, between 100 and a 1, it has no value at all, correct? So it's still a digit, okay? So which means I can include 0 here. 0, 1, 3, 5, 7, 9, right? Okay, now I might be wrong because it may get into a position here where they're not including this, but let's see. So how many do I have? 1, 2, 3, 4, 5, 6. So I might disagree with the book's answer on this because it's still going to force it. It says how many three-digit counting numbers less than 700. I think that there might be excluding 0 on this because they're going to count 0 as an even number even though it's in between. Okay, so I think that they're probably just going to count this as a 5 because they're not going to allow 0 in as part of that. Okay, so they're just going to take 1, 3, 5, 7, and 9. Okay, and then we should get the exact same values for our ones digit. So I get a 5 here and here. So if they're asking for how many, we end up taking 3 times 5 times 5, okay, which is what? 75. So there are exactly 75 numbers that are 3 digits where all the digits are odd that are less than 700. So do we see how we're talking about conditional permutations? We've set constraints upon what numbers I can use, but it's still really not super difficult so long as we understand the rules that are being placed on every individual question. Okay? All right, we understand how to get there? All right, let's go back. Let's erase this one and come back. Okay? 4 math books, 6 lit books are on a shelf. How many ways can they be arranged if the math books are kept together and the lit books are kept together? Okay. Let's come back over here. You guys are going to keep this page in mind as we look at this. All right. Now, how many math books were there? There were 4 math books, right? So let's take math and let's call them 1, 2, 3, and 4. Now, they're individual, right? They're individual math books, okay? And then we have lit books, okay? And there are how many of those? 6? 1, 2, 3, 4, 5, and 6. Okay? Now, 4 math books and 6 lit books are on a shelf. How many ways can they be arranged if the math books are kept together and the lit books are kept together? Okay? All right, so let's start. We have to keep them together. So naturally, we would put the math books first, correct? Because we're in algebra class, we're going to put our math books first. Okay? 1, 2, 3, 4. Okay? Once I pick how many of these books could go first? 4. Second? 3, 2, 1. So I wind up with 4 factorial, right? Okay? And then the lit books. Okay? Okay? It should be 6 factorial, correct? It's going to go 6, 5, 4, 3, 2, and 1. Okay? So I could really easily take 4 factorial times 6 factorial and get a number, right? What do I get? 17,000. What do you say? 280. Now, there's only one problem with this, is that we are missing one condition. And that condition was that the math and the lit books had to be kept together, but it didn't say which order, right? So what could I do with this? Could I have put the lit books first and the math books second? And would that change the number of ways I could order them? Yeah, it would. Because this would no longer be 4, right? We're saying how many different ways I could order them, right? So there are 4 books that could go here if I put math books first. So what I'm saying is that we can double the ways that we do this, okay, by taking 17,280 and multiplying it by 2, because what I'm going to get is plus 6 factorial times 4 factorial. You see what I'm saying? Okay, because I could have put those 6 lit books first and then the 4 math books after that. Okay, so I should get an answer of 34,560. There are 34,560 ways that I could order those books given those conditions on my permutations. Okay, are you still with me?
Yeah.
Okay, great.
The entire time I thought you were going to dab these ones, but you said lit books.
Lit books. Yeah. Okay. I think if I'm going to dab on a lesson like this, I really need to get a camera so that, so that everyone can see how lit my lessons really are. I'm going to become a vlogger. Okay. Number 3, how many ways can the letters A, B, C, D, and E be arranged in a row of 4? Now, how many letters are there? There's 5, right? Be arranged in a row of 4 at a time if neither E nor C can be second and B must be third. Repetition is permitted. All right, so that gets into a lot of stuff, right? So you're going to hold on to this page. I'm going to go back over so we can draw this stuff out. All right, now what we said is that we had 4, correct? All right, so now we have to follow the rules and find out how many of them can go in the first slot. Okay, now I'll read it again. How many ways can the letters A, B, C, D, and E be arranged in a row of 4 at a time if neither E nor C can be second, and B must be third. All right, so of those 5, how many of them could be first? All 5 of them, because remember, repetition is permitted.
B has to be third though.
Repetition is permitted. So B could be first and third. You see what I'm saying? Okay, so we could have all 5 of them can fit in that first spot, right? Okay. How many ways can the letters A, B, C, D, and E be arranged in a row of 4 at a time if neither E nor C can be second? All right, so that changes how many can go in this first spot, right? How many can go in there? Only 3, right? Because we're taking 2 out of that. All right, now does it say anything about what has to be in the third spot? B must be third. So B has to fill that spot, which means nothing else can. It eliminates the possibility for anything else, which means there's just 1 that can go there, right? Now, does it say anything about the 4th slot? Which means because repetition is permitted, how many of them can go in the 4th slot? 5. What do I do with these numbers? Multiply them. 5 times 3 times 1 times 5, which is really 15 times 5, which is 75. Okay? Does this seem as hard as it sounds? I don't know. That's kind of a weird question to ask. Okay? All right. Let's see. How many ways, how many 3-digit counting numbers less than 300 have digits that are all odd? This is a nod back to question number 1. We could probably do this just right here next to it. 3-digit counting numbers that are less than 300 that have all the digits that are odd. Remember, 0 is an even number. Okay? So what possibilities do I have for the 100 slot? 1 and, yeah, just 1, right? Only 1 will go there because I have to have something, okay? And I can't have 3, okay? All right, but what can go in the 10 slot? 5, because I got 1, 3, 5, 7, and 9. What about the 1 slot? 5. So I wind up with a total of how many different possibilities? 25. Okay, 25. All right, good. So we get an understanding at least of how to do conditional permutations, right? Okay. All right, now we're going to get into questions number 5 and 6. And questions number 5 and 6 require us to get our graphing calculators out. Okay, does everybody in here have one? Yes, you may. Uh-huh. Okay, so we're going to take the information. The first thing that we need to identify, notice that they take the slope-intercept form of the equation and they plug in different variables for it. So usually we see it as y equals mx plus b, but they're writing it as g equals mh plus b. So you'll notice that they're changing y to g and x to h. So what I'm going to do over here is I want to identify, because I don't think in g equals mh plus b, I think in y equals mx plus b. So I want to go over here and I'm going to write next to GPA, I'm going to write y. I'm going to come down here to hours of TV and I'm going to write x. Okay? Because normally, if I don't do that, I'm going to assume that the top row is x and the bottom row is y, because I think xy. Okay? So you understand why we did that, so that we don't end up getting things out of order. And that's going to be important as we bring up this, because what I'm going to do, let's clear this out, is we're going to go into stat, and we're going to edit our list. Now, it should be clear already. Usually the easiest way to do this, you can go in and you can clear the whole list, or you can just go in and on each individual item, if you have something in there, and just hit delete. You guys know how to do that? Okay. All right, so list 1 is going to be x, list 2 is going to be y. Okay? Which is why it's important to identify what we're putting in. So 1.6 is going to go in first. 1.6, 1.6, 2.6, 1.8, and 2.3. Okay, and we're going to go over to list 2, 3.8, 3.7, 2.3, 3.4, and 2.6. Okay, once we have that, hopefully if I haven't done anything wrong here, you see what I'm saying? Hopefully we're doing okay here. Yep, we've done it in Algebra 2. We go back to our stat. We want to come over to calculate. We want one variable statistics. Hold on. No, sorry. We want linear regression AX plus B. Okay, that's what's going to put it in my slope-intercept form. Okay, so what you'll see here is that they're saying y equals AX plus B, where A, which is my slope, is negative 1.5, and my slope is 6.1. So the answer here, we would write, y, oh, I lost my stuff there. It'll let me write and look at it at the same time. Y equals negative 1.4x plus, what was it, 6.1?
Yeah.
Okay. Okay, and that's all I need there.
Can you do that with any coordinate stuff that it gives you, and it'll give you the line?
If you have x and y values, yeah, you can do that. Okay. All right, the other thing that it wants in here is that it also wants you to find the correlation coefficient for this data. Now, you'll notice as I pull that back up here that it didn't give me any correlation coefficient. And if you remember this from Algebra 2, the correlation coefficient shows up in your graphing calculator as an R value. Okay? And that R value, the closer it gets to -1 or +1, is showing you how close that data is to being a straight line. The further away it gets from either -1 or +1, the more scattered the data is. But we need to do some stuff with our calculator in order to get it to do that. And what we're going to do to pull up that R value is we're going to hit second catalog. And we're going to go all the way down to diagnostic on. And every time you have to reset your calculator for some reason, it's going to turn diagnostic off. Okay, so if you ever have to reset your calculator, you're going to have to go back in to second catalog and turn that diagnostic back on. You may have to hit enter several times on this one. I only have to hit it once. I'm going to go back into stat. I'm going to hit linear regression again. And notice that it gives me an R value this time. And I don't really need the R squared value. I'm just looking at this. Notice that it is almost exactly a straight line because it's negative 0.99, okay, which means my data is pretty well in a straight line. Given all these different data points, I should be able to connect them, okay? So if it had been negative 0.01, right, it would have been a very scattered set of data, okay? So my R value is negative 0.9, or really -1. Which means all that negative means is that that line is going down from left to right. Go ahead.
So it can't go above 1, right? Like the R value cannot be above 1.
No.
1 is a perfect line.
1 is a perfect line, and -1 is a perfect negative line. Okay?
Farther away from 1, more it's scattered out.
Right.
Okay.
So as it approaches 0.0 something, okay, the more scattered that data is, it's going to look like a shotgun blast if I plotted that data. Okay? All right. For sake of time, I'm probably not going to do number 6. I think you guys have an understanding of how to do it based upon what we did with number 5. Does that make sense? Okay? But so that you know what you're doing, if you want to do it and look at it, your answer for 6 is going to be C. Okay? All right, so let's erase all of this. We really only have one concept left, which is 7 8, 9, and 10. And this comes from our lesson 46 information, which is complex roots factoring over the complex numbers. Okay. So in this one, it says write the quadratic equation with a lead coefficient of 1 whose roots are 1 plus 3i and 1 minus 3i. So we've seen questions like this where it would say, what is the quadratic equation if x equals negative 3 and x equals positive 4? If we had something like x equals positive 3 and x equals negative 4, then I'm going to move those things across so that I get x minus 3 times x plus 4, and then I'm going to FOIL that back out until I get a quadratic equation, right? But because we're doing this with a complex set of numbers where they're saying x equals 1 plus 3i and x equals 1 minus 3i, what we're really saying is x minus 1 plus 3i times x minus 1 minus 3i, right? And we would have to FOIL all of that out in order to get it. You follow me? But we don't have to do that much work because we're going to use a shortcut set of tools with our 1 plus 3i and our 1 minus 3i. Now, I'm guessing that you might be asking, why is there a negative in front of both ones?
No, I was just...
No? Okay. So what we're going to do here is what is called the sum product. Okay? The sum product. Where we're doing 1 plus 3i plus 1 minus 3i. Okay? So the first thing we do is the sum. We add those two things together. Well, what happens to 3i and negative 3i? Cancel out. 1 plus 1 is 2. Now, what I want you to understand about the sum is that when I go to put it in the quadratic, it's always going to be the opposite sign of what I get from my sum. So far what I know is I'm going to get x squared minus 2x. Okay? Now, for the product, I'm taking 1 plus 3i times 1 minus 3i. This is the product portion. Now, what I should get out of almost every one of these is that I'm going to see that it's a sum difference, right? So I'm going to do 1 times 1, which is 1. And because it's a sum difference, do I need to do the middle two terms? Do I need to do inner outer? No, I just need to do last, which is 3i times negative 3i. Well, what's 3 times negative 3? And what's I times I? I squared is... So what is negative 9 times negative 1? 9. Which is 10. And this one stays exactly the way that it is. Okay? So my answer, hopefully I've got this right and I'm looking at it right, is x squared minus 2x plus 10. And we want to finish it off by saying that it equals 0. Question?
Yeah, why is it negative 2 not again?
Because it is. Whenever we go and if we had to put this back into, let's say, the quadratic equation, our negative b plus or minus the square root of b squared minus 4a, minus 4a all over 2a, I'm going to get the negative 2. Okay?
But if the sum was negative 2, would it be a positive?
It would be a positive 2. Yep. It's going to be the opposite of whatever this winds up being. Okay? All right. So let's do another one and see how we do. Okay? Okay, which should bring us to question number 8. All right, write the quadratic equation with a lead coefficient of 1 whose roots are 3 plus 3i and 3 minus 3i. Sum, right? Sum first. 3 plus 3i, 3 minus 3i. What happens to the i's? 3 plus 3 is 6, so I'm writing x squared what? Minus 6, We want in the quadratic equation, so it's x. Okay? 3 plus 3i times 3 minus 3i. Product. 3 times 3 is 9. Okay? Which is positive 9. 9 plus 9 is 18. So I wind up with x squared minus 6x plus 18 equals 0. That's going to be a lot quicker. I don't think that your book would have you FOIL all of it, which takes a lot more time, because then you end up having to combine like terms and do all these different things. You see how much quicker this is, right? I could teach you the harder way, but I feel like it would be a waste of time to show you something harder to prove that this way is easier. Okay? Trust me, this is easier. Okay? Does everybody in here understand how to do this so far? Okay? Now we're going to take it and we're going to go backwards. It says factor x squared minus 2x plus 10. Well, notice that was the answer to number 7, right? So we know that we should get 1 plus 3i and 1 minus 3i, right? Okay, so let's make sure that that actually works. So what we're going to do here is our quadratic equation. Do we remember our quadratic equation? Negative b b squared. Okay, now what is, what do I have here in x squared minus 2x plus 10? What's what here?
2 goes outside. Well, 2 is B.
2 is B, 10 is C, 1 is A. Good. All right, so what does this mean, this negative B? Opposite sign, right? So I'm going to put what? 2 plus or minus the square root of negative 2 squared. Making sure to put that negative 2 in parentheses, because whenever I square a negative number, if I don't put a set of parentheses, it's going to leave it as a negative. Okay, minus 4 times 1 times 10 all over 2 times 1. Okay, so I've got 2 plus or minus. Negative 2 squared is 4, so that's 4 minus 40, right? Which is negative 36 over 2. How can I simplify square root of negative 36? What is that? 6i. Good. So I've got 2 plus or minus 6i over 2. 2 divided by 2 is what? 1. Plus or minus, what's 6i divided by 2? 3i. So x, what I end up putting in here is I get, this is how they want the answer. This is correct, but what they want to see is they want to see x minus 1 plus 3i times x minus 1 minus 3i. This is the answer that they want to see there. Okay? I probably give you half credit on that. Okay? So I'm trying to tell you right now, write this down in your work so that you're seeing that this is what, because they said over a set of complex numbers, so they want that whole thing. Okay? All right. And you'll notice on 10 puts it in that format. Okay? Now, I believe what we saw with 8 matches up with what we saw in 10, right? Okay, because I think that what we got was x squared minus 6x plus 18. So we should get the 3 plus 3i, 3 minus 3i, which means we need to see that minus in both places. So I want to say that you're going to get A for your answer there. Okay? Does that make enough sense for you guys to get a pretty good start on things? Okay. All right, we'll close it out right there. You guys got about 9 minutes to work. And I don't think that this lesson is extremely long.